Let's take a look at how we can put what we know about the 4 quantum numbers together to count how many electrons and how many orbitals we've got in a shell or a subshell. Let's take the third shell. Suppose we want to know how many orbitals are there in the third shell? How many subshells are there? How many electrons are there? One way to do that is with a tree diagram. You can use the restrictions on the quantum numbers to write down all the possibilities, like branches on a tree. And then you can count what you've got at different levels. Now here I'm in the third shell. This is kind of the root of the tree. Now, what I want to do next is list all the subshells that are in the third shell. Okay, well, these are the L values that I'm allowed to have. And L can go from 0 up to n minus 1. So I am allowed to have any of those. Now what's the subshell that I have at that point? The code for L equals 0 is S. So this is a 3S subshell. The code for L equals 1 is P. So this is a 3P subshell that I have here. And the code for this one is D. So I have a 3D subshell here. Okay, so I have 3 subshells in the third shell, I can say, and their names are 3s, 3p, and 3d. Now let's figure out what orbitals I can have. Every m sub L value that I can have is an orbital. So let's figure out how many m sub L values I can have for each of these L values. For this one, for L equals 0, I have to go from minus L up to plus L through 0. So I can go from minus 0 to plus 0, which is just 0. So your m sub L value has to be just that. So there's only one orbital. So what I can say at this point is that in a 3s subshell, there's only one orbital. Alright, what about this one? The m sub L values here can be minus L up to plus L. So they can be minus 1 or 0 or plus 1. So there are basically 3 different m sub L values. Let me put m sub L as a column heading up here, and that way I won't have to keep on saying m sub L equals. So there's 3 branches there, and that means that there are 3 orbitals in the 3p subshell. This contains 3 orbitals. Now how about the D? Okay, my m sub L values can be minus L up to plus L, so they can be minus 2, minus 1, 0, plus 1, or plus 2. So there are 5 branches on the tree there. So I can have 5 orbitals. So there are 5 orbitals in the 3D subshell. How many orbitals altogether in the third shell? 1 plus 3 is 4, plus 5 is 9. There are 9 orbitals in the third shell. So I can count subshells. There's 3 of them. I can count orbitals. There's 9 of them. How about electrons? There I need the m sub s values. And there's 2 possible values, plus 1/2 or minus 1/2. And you can fit a 1/2 in there or a minus 1/2 in there. So in the 3s subshell, there's 1 orbital which can fit 2 electrons. Each value of m sub s that's possible is 1 electron. So I got 2 electrons here that can fit in that orbital. Now, every orbital can fit 2 electrons, plus 1/2 and minus 1/2. And it's going to get kind of tedious for me to keep writing in the plus 1/2 and the minus 1/2, so I'm going to just write 2 leaves on the end of every branch here. So how many electrons can fit in the 3p subshell? 3 orbitals can fit in there. Each orbital can hold 2 electrons. So there are a total of 6 electrons in the 3p subshell. See? 3 orbitals, each holds 2, gives you 6. How about this D subshell? How many electrons can I have in there? Well, I can have 2 leaves, 2 m sub s values, for each one of these. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. That can fit there. So how many electrons altogether can you have in the third shell? 2 plus 6 is 8, plus 10 is 18. You can have 18 electrons altogether in the third shell. 18 electrons in 9 orbitals in 3 subshells. So you'll get questions that will ask you to count electrons, orbitals, and subshells that are in a shell. And this is the best way to do them.